Alright, hey guys. Alright, so we should be streaming. We should be good. Should be good right now. Guys, please like the video. Alright, so we should be. Please like the video. Please enjoy this live stream. Today we're going to be completing the pre-security. So let's get it started. Let me just adjust. Let me just adjust something, guys. Alright, so now we're good. So let's get started, guys. So here I have a company with me, some crystal glacier water, and so yeah, so this has some electrolytes. This is Santa Cruz paleo electrolytes. So I'm trying to drink a lot of water because it reduces face bloating. But not only that, water is really good, and it's one of the fundamentals of the earth and everything. So let's get started to this. Let's have our first drink of the stream. All right. Okay. So sorry, I'm just watching me get my first drink in. Oh, hold on. This seems like. Let me fix this for you guys. There we go. That's perfect. Like the face when I'm concentrating is actually so interesting. All right, so let's get started.
Hey everyone, welcome back to another video here on Tryhackme. Today we're going to be taking a look at the room.
Alright, did these. So I guess I'm good to move on.
Hey everyone, welcome back to another video here on Tryhackme. I'm John, and today we're going to be taking a look at the room Intro to LAN. Learn about some of the technologies and designs that power private networks. That being said, let's go ahead and dive right into task 1, introducing LAN topologies. Local area network, LAN topologies. We'll go ahead and click the view site. I think it's already loaded, but we'll just make sure. Over the years, there have been experimentation and implementation of various network designs. In reference to networking, when we refer to the term topology, we're actually referring to the design or look of the network at hand, so how everything's actually connected. Let's discuss the advantages and disadvantages of these topologies below. First, let's talk about the star topology. The main premise of a star topology is that devices are individually connected via a central networking device, such as a switch or a hub. This topology is the most common found today because of its reliability and scalability, despite the cost. Any information sent to the device in this topology is sent via the central device, which connects everything. Let's explore some of these advantages and disadvantages of the topology below. Because more cabling and the purchase of a dedicated networking equipment is required for this topology, it is more expensive than any of the other topologies, and we'll discuss a few more below. However, despite the added cost, this does provide some significant advantages. For example, this topology is much more scalable in nature, which means that it is very easy to add more devices as the demand for the network increases. Unfortunately, the more the network scales, the more maintenance is required to keep the network functional. This increased dependence on maintenance can also make troubleshooting faults much harder. As there's more places, there's more cables, there's more things to go wrong in general. Furthermore, the star topology is still prone to failure, albeit reduced. For example, if the centralized hardware that connects devices fails, these devices will no longer be able to send or receive data. Thankfully, these centralized hardware devices are often very robust. Switches, they don't die very often, and when they do, it's very obvious that they're dead, and it's pretty easy to replace them. They're usually not terribly expensive as well, as far as networking hardware goes. As you get ones with nicer features, they definitely go up in price, but for just a basic one for home use, they're like $25 or something like that, which on the scale of networking things, that's not too bad. But you can see in this how everything's connected via a central hub. Bus topology. This type of connection relies on a single connection, which is known as the backbone cable. This type of topology is similar to the leaf off a tree in the sense that the devices, or leaves, stem from where the branches are on the cable. Because all data destined for each device travels along the same cable, it is very quickly prone to becoming slow and bottlenecked if devices within the topology are simultaneously requesting data. This bottleneck also results in very difficult troubleshooting because it quickly becomes difficult to identify which device is experiencing issues with data all traveling along the same route. However, with this said, bus topologies are often one of the easier and more efficient topologies to set up because of their expense. And you can see that there's this big connecting thing that there's not a lot of cabling involved there because you just have one dedicated mega cable. Because of their expenses such as cabling or dedicated network equipment used to connect these services. So lastly, another disadvantage of the bus topology is that there is a little redundancy in place in case of failures. This disadvantage is because there is a single point of failure along the backbone cable. If this cable were to break, devices can no longer receive or transmit data along the bus. Let's talk about ring topology. The ring topology, also known as token topology, boasts some similarities. Devices such as computers are connected directly to each other to form a loop, meaning that there is little cabling required and less dependence on dedicated hardware such as networks or switches or things like that within the star topology. A ring topology works by sending data across the loop until it reaches the destined device. Using other devices along the loop will they'll forward the data. So essentially it just gets passed along these points. Interestingly, a device will only receive data from another device in this topology if it does not have any to send itself. If the device happens to have data to send, it will send its own data first before sending data from another device. Because there is only one direction for data to travel across this topology, often counterclockwise or clockwise, just one of the two, it is fairly easy to troubleshoot any faults that arise. So for example, if you had a break right here, and suddenly this device can't receive data from this device, well, fairly obvious that the cable's probably bad there. However, this is a double-edged sword because it isn't an efficient way of data traveling across a network, and it may have to visit multiple devices first before reaching the intended device. Lastly, ring topologies are less prone to bottlenecks, such as within a bus topology, as large amounts of traffic are not traveling across the network at any time. The design of this topology does, however, mean that a fault such as a cable cut or a broken device will result in the entire networking breaking or just failing altogether. One thing to note here, this is less common to see. This is something that you would probably see if you have a mesh network, that it might leverage a ring topology to pass things between those different nodes in the network. However, that's not exactly all that common. The one that you're likely to see in most cases is probably this star, just because it's very common, it's very easy, and often enough in your home network, this is probably what you're using anyways, where you have one router that has a Wi-Fi access point on it and everything connects to the same access point. So just be aware of that. This is probably the most important one, but you do need to know about these other topology types. Let's talk about what is a router. It's a router's job to connect networks and pass data between them. It does this by using routing, hence the name router. Routing is the name or the label given to the process of data traveling across networks. So, what do we mean when we say across networks? This means networks with different addressing schemes. So, maybe I have a home network and you have a home network. But if I want to send something to you, maybe an email, that has to cross the public internet too. So, we have our routers that sit on the edges of those networks. So, where the internet comes into my house at what's called the demarc point, and then where it comes into your house at the demarc point there. And that does the translating. It handles how routes are created. And when I say routes, I mean general rules of how you can talk to devices across those networks. So it uses the desk.
Wait, hold on. Can I get this in like dark mode? There we go. That's better. Okay. Oh shoot. Hold on, guys. I'm just gonna break this a little bit. I don't know if that's better for you guys. Shoot. Hold on, guys. I'm just gonna break this a little bit. I don't know if that's better for you guys. All right. All right. All right. So what is a switch? Switches are dedicated devices within a network that are designed to aggregate multiple other devices, such as computers, printers, or any other networking capable device using Ethernet. These various devices plug into a switch's port. Switches are usually found in larger networks such as businesses, schools, or similar sized networks, where there are many devices connected to a network. Switches can connect a large number of devices by having 4, 8, 16, 24, 32, and 64 ports for devices to plug into. Switches are more efficient than their lesser counterpart hubs/repeaters. Switches keep track of what device is connected to which port. This way, when they receive a packet, instead of repeating that packet to every port like a hub would do, it just sends it to the intended target, thus reducing network traffic. Okay, so here we have internet router. It goes to the switch. The switch is many. Internet router switch goes into menu. All right, both switches and routers can be connected to one another. The ability to do this increases the redundancy, the reliability of a network by adding multiple paths for data to take. If one path goes down, another can be used. While this may reduce the overall performance of a network because packets have to take longer to travel, there is no downtime, a small price to pay considering the alternative. What is a router? A router's job is to connect networks and pass data between them. It does this by using routing, hence the name router. Routing is a label given to the process of data traveling across networks. Routing involves creating a path between networks so that this data can be successfully delivered. What is a router? A router's job is to connect networks. All right. Routing is useful when devices are connected by many paths, such as in the example diagram below. So here we have computer A. We have the first router, and it has two directions. So if we take this path, it goes here, but it all leads to the same other computer. So it's like to network data so that it can be successfully delivered. What does LAN stand for? That's local area network. What is the verb given to the job that route is performed? The verb is routing, right? Yeah. Essentially connect multiple devices on the local network. Isn't that above us? Is that a switch? Let's see. Let's go. It's cost efficient to set up. So I can wear the star. This one's the expensive one, boss. Sorry, bus. This the cost efficient one. Yeah, because it's not like connected to like a router going into many. It's just one route and it's just split. So let's put in bus. What topology is expensive? What did I just do? I pressed like a key on my mouse, guys. What topology is expensive to set up? Is the a star. Complete the interactive tab attached.
Hey, folks. In order to map these two identifiers together, the advantages of the topology below. This does provide some significant advantage. Go wrong in general.
I'm confused. Like, when is it gonna end?
For example, this topology is much more scalable. Keep the emails. These devices will no longer not tear their feet. It's not too bad. But you can see in this how everything's connected via a central hub. Bus topology. This type of connection relies on a single connection, which is known as the backbone cable. This type of topology is similar to the leaf off a tree in the sense that the devices, or leaves, stem from where the branches are on the cable. Because all data destined for each device travels along the same cable, it is very quickly prone to becoming slow and bottlenecked if devices within the topology are simultaneously requesting data. This bottleneck also results in very difficult troubleshooting because it quickly becomes difficult to identify which device is experiencing issues with data all traveling along the same route. However, with this said, bus topologies are often one of the easier and more cost-effective or efficient
Let's go. Alright, so I got it. With a star topology, all devices are connected with their own cable to a central switch hub. Alright, every packet is sent through the switch. Okay, so it's like a delivery man. Let's see if you can somehow break the switch. So I have a hammer. Network is down. I broke the switch. Alright, so let's put in. So we got the key. Guys, please make sure you like. Make sure you like. Alright. So that was cool. There we go. And we can take this away. Let's move on to the second one, test 2. After each task, I'd like to drink a little bit of water. As we previously discussed through the module so far, networks can be found in all shapes and sizes, ranging from small to large. Subsetting is the term given to splitting up a network into smaller, miniature networks within itself. Think of it as slicing up a cake for your friends. There's only a certain amount of cake to go around, but everybody wants a piece. Subnetting is you deciding who gets what slice and reserving such a slice of this metaphorical cake. Take a business, for example. You will have different departments, such as accounting, finance, and human resources. Okay, so we have the internet, we have the router. The router is going to the switch, so the router is making the route for the internet into the switch. And then here you have the switch is the different types of things under that business. Well, so you know where to send information in real life to the correct department. Networks need to know as well. Network administrators use subnetting to categorize and assign specific parts of a network to reflect this. Subnetting is achieved by splitting up the number of hosts that can fit within a network, represented by a number called a subnet mask. Let's refer back to our diagram from the first module. From the first room in this module. So we have octet 1, octet 2, octet 3, octet 4. Okay, I understand this. So as we can recall, an IP address is made up of 4 sections called octets. The same goes for subnet mask, which is also represented as a number of 4 bytes, 32 bits, ranging from 0 to 255. Subnets use IP address in 3 different ways: identify the network address, identify the host address, identify the default gateway. Let's split these 3 up to understand their purposes into the table below. Network address. This address identifies the start of the actual. Sorry. This address identifies the start of the actual network and is used to identify a network's existence. For example, a device with the IP address of 192.168.1.100 will be on the network identified by 192.168.1.0. Then we have the example on the right, host address. An IP address here is used to identify a device on the subnet. For example, a device will have the network address of 192.168.1.1. Alright. Default gateway. The default gateway is a special address assigned to a device on a network that is capable of sending information to another network. Any data that needs to go to a device that isn't on the same network will be sent to this device. These devices can use any host address, but usually use either the first or last host address in a network. Now, in small networks such as at home, you will be on one subnet. You'll be on one subnet, as there is an unlikely chance that you need more than 254 devices connected at the same time. However, places such as businesses and office will have much more of these devices where subnetting takes place. Subnetting provides a range of benefits, including efficiency, security, full control, and we'll come on to explore exactly how subnetting provides these benefits at a later date. However, for now, all we need to understand is the security element to it. Let's take the typical cafe on the street. This cafe will have two networks, one for employees, cash registers, and other devices for the facility, one for the general public to use as a hotspot. Okay. Subnetting allows you to separate these two use cases from each other whilst having the benefits of a connection to larger networks such as the internet. Okay. 32. 02255. What address? Network address. Guys, do not come at me for not knowing how to spell address. Am I right? Like, why is it doing it? Like, does it add suspense? Like, do they want to add suspense to this? Let's go. To identify devices within a network, it's an IP. No, not an IP. Is it host? Host address? Guys, I've always had trouble spelling. What is the name used to identify the device responsible for sending data to another network? Oh my gosh. Oh my gosh. Default gateway. Let's go. Let's go. Alright, so we got that done. Task 3. Alright, so recalling from our previous task that devices can have two identifiers, a MAC address and an IP address. The Address Resolution Protocol, or ARP for short, is a technology that is responsible for allowing devices to identify themselves on a network. Simply, ARP allows devices to associate its MAC address with an IP address on the network. Each device on a network will keep a log of the MAC address associated with other devices. When devices wish to communicate with another, they will send a broadcast to the entire network searching for a specific device. Devices can use ARP to find the MAC address and therefore the physical identifier of a device, which leads to the communication between those two devices. Alright, so each device within the network has a ledger to store information on, which is called a cache. In the context of ARP, this cache stores the identifiers of other devices on the network. In order to map these two identifiers together, IP address and MAC address, ARP sends two types of messages, an ARP request and an ARP reply. When an ARP request is sent, a message is broadcasted on the network to other devices asking, what is the MAC address that owns this IP address? When the other devices receive that message, they'll only respond if they own that IP and will send an ARP, however it's saying RIP, okay, with its MAC address. The requesting device can now remember this mapping and store it in its ARP cache for future use. Okay, so this one is sending, so this is the MAC, this is the all information. Who has the IP address? Boom, 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 boom. I have it. So, and then it saves. Um, Dang it, address resolution protocol. Uh, No. What category? It's this one, but like, what does it like? What is it talking about? Like a ARP request? A request? Okay. All right. A Mac. All right. So IP addresses can be assigned either manually um, by entering them physically into a device, or automatically and most commonly by using DHCP, Dynamic Host Configuration Protocol. Server. Okay. When a device connects to a network, if it has not already been manually assigned an IP address, it sends out a request, DHCP, which is the Dynamic Host Configuration Protocol discovered, to see if any Dynamic Host Configuration Protocol servers are on the network. The DHCP server then replies back with an IP address. The device could use DHCP offer. The device then sends a reply and confirming it wants the offered IP address. And then lastly, the DHCP server sends a reply acknowledging this has been completed. And like, okay, and the device can start using the IP address. So this they discover. Okay, hey, I'm new here. Is there anyone who can give me an IP address? Hey, sure thing. You can have this one. Yes, that would be brilliant. I'll start using this. Okay, great. You can use the IP address for the next 24 hours. Alright, so we're gonna join this room. So let's log into this. Oh. Wait, what did I not complete? I gotta make sure I join everything. Oh, that's part of it, okay. Alright, so the OSI model is an essential model used in networking. This critical model provides a framework dictating how all networks devices will send, receive, and interpret data. One of the main benefits of the OSI model is that devices can have different functions. Oh, guys, my dad's calling me. Alright, so the open systems interconnection model is an essential model used in networking. This critical model provides a framework dictating how all network devices will send, receive, and intermediate. What are the main benefits of it? Open systems interconnections model is that devices can have different functions and designs on a network while communicating with other devices. Data sent across a network follows the uniformity of the OSI model and be understood by other devices. The OSI model consists of 7 layers which are illustrated in the diagram below. Each layer has a different set of responsibilities and is arranged from layer 7 to layer 1. At every individual layer that data travels through, specific processes take place and pieces of information are added to this data, which is what we'll come to discuss in the upcoming tasks within this room. However, for now, we only need to understand that this process is called encapsulation and what the OSI model looks like in the diagram below. We have application presentation session, transport network data link, and physical. Okay. So we have OSI. That's the open interconnection. Oh, sorry, open system. No, open system. Yes, interconnections. 7. Encapsulation. Oh, let's read it, guys. This layer is one of the easiest layers to grasp, but put simply, this layer references the physical components of the hardware used in networking and is the lowest layer that you'll find. Devices use electrical signals to transfer data between each other in a binary numbering system, ones and zeros. For example, Ethernet cables connecting such as the picture below. Okay, so it's physical. Um, Numbering system is binary. Binary, like everybody binary, you guys. Let's lock in. What is the name of it? Ethernet? No. Connected. This is Ethernet. Ethernet cables. The data layer link layer focuses on the physical adjusting of the transmission. It receives a packet. Hold on, let me check something real quick, guys. Alright, so this data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer. Hold on. Data link layer focuses. Alright, the data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address for the remote computer, and adds in the physical MAC, the media access control. The address of the receiving endpoint inside every network-enabled computer is a network interface card. This comes with a unique MAC address to identify it. MAC addresses are set by the manufacturer and literally burnt into the card. They can't be changed, although they can be spoofed. When information is sent across a network, it's actually the physical address that is used to identify where exactly the information is coming from. Additionally, it's also the job of the data link layer to present data in a format suitable for transmission. So I guess this one focuses on the okay. Okay. So this is the data link. This cable's in the way, guys. The, they come with a network interface card. Alright, so the third layer of the OSI model, which is the open systems interconnections. Yep. Is where the magic of guys, take some water real quick. Let's take some water real quick. I should have gotten some gushers. Logan craves some gushers. Third layer of the OSI model is where the magic of routing and reassembly of data takes place. First, routing simply determines the most optimal path in which these chunks of data should be sent, while some protocols at this layer determine exactly what is the optimal path that data should take to reach the device, which only know about their existence at the stage of the networking module. Briefly, these protocols include OSPF, Open Shortest Path First, or RIP, routing information protocol. The factors that decide what route is taken is decided by the following: what path is the shortest, or has the least amount of devices that the packet needs to travel across? What path is the most reliable? Have packets been lost on that path before? Or which path has a faster physical connection? And is one of the paths using a copper connection slower or fiber considerably faster? At this layer, everything is dealt with via IP addresses such as 192.168.100. Devices such as routers capable of delivering packets using IP addresses are known as layer 3 devices. Devices such as routers, okay, because they're capable of working at the third layer of the OSI model. So network is just networking, it has like what's the shortest path, most reliable and the fastest. Computer A, so here was the networking. We saw this earlier. Network. What packets? Take the most. Yes, like the. What acronym OSPF? So that's the open. Uh, oh shoot, yeah, open shortest path first. Open shortest path first. That stands for what does routing information protocol. What type of addresses are dealt with this layer? IP? Yeah, IP addresses. IP addresses. Therefore, transport. here. So, because after we do like layer 4, layer 5, 6, 7, 6, 7, oh. Oh, okay, so we're gonna get some ghosters because I need something sweet. Larger transport layer 4 of the OSI models plays a vital part in transmitting data across a network and can be a little bit difficult to grasp. When data is sent between devices, it allows one of two different protocols that are decided based upon several factors, TCP and UDP. Let's begin with TCP, the Transmission Control Protocol. Potentially hinted by this name, this protocol is designed with reliability and guarantee in mind. This protocol reserves a constant connection between the two devices for the amount of time it takes for the data to be sent and received. Not only this, but TCP incorporates error checking into its design. Error checking is how TCP can guarantee that data is sent from the small chunks in a layer. Layer 5 has then been received and reassembled in the same order. So advantages of TCP, we have guarantees the accuracy of data, requires disadvantages requires a reliable connection between the two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. We have another advantage which is capable of synchronizing two devices to prevent each other from being flooded with data. A slow connection can bottleneck another device as the connection will be reserved on the receiving computer the whole time. Performs a lot more processes for reliability. TCP is significantly slower than UDP because more work has to be done by the devices using this protocol. TCP is used for situations such as file sharing, internet browsing, or sending an email. This usage is because these services require the data to be accurate and complete. No good having a half file for real. In the diagram, we can see how a picture of a cat is broken down into smaller pieces of data from the web server, where the computer reconstructs the picture of the cat into the order. Okay. This R2CP cuts down shorter data to or packets here. Alright, now let's move on to user datagram protocol, UDP for short. This protocol is not nearly as advanced as its brother, the TCP, which is let's have a transmission control. So TCP is transmission control, and this one's user datagram. This protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast many features offered by TCP, such as error checking and reliability. In fact, any data that gets sent via UDP is sent to the computer, whether it gets there or not. There is no synchronization between the two devices or guarantee just hope for the best finger crossed. While this sounds disadvantageous, it does have its merits, which we'll layer in the table. UDP is much faster than TCP. It leaves the application layer user software to decide if there is any control over how quickly packets are sent, and UDP does not reserve a continuous connection on a device as TCP does. This disadvantage is UDP doesn't care if the data is received. It is quite flexible to software developers in the sense. This means that unstable connections result in a terrible experience for the user. Using the same examples as before, we can see how the only one had been received by the computer, meaning that half of the image is missing. Okay, UDP is useful in situations where there are small pieces of data being sent. For example, protocols used for discovering devices are ARP and DHCP that we discussed in room 2, or large files such as video streaming where it is okay some part of the video is pixelated. Pixels are just lost pieces of data. Alright, so this one is transportation. No, transport. I said transportation. Oh shit. It says may not be in English. That's crazy. So this one is transmission. No. Let me log it, guys. What am I doing? Transmission control protocol. What did I spell wrong? Can we like clip that? Like what did I spell wrong? This one is UDP. Open user datagram protocols. Frick, dude, I had that. Don't clip me, chat. Do not clip. Protocol. Alright, well, there's your data. So that is the TCP. And doesn't carry UDP. So TCP. TCP. What protocol? UDP. Yeah! Let's go! Let's go, man! Let's go, chat! Let's go, chat! Let's go, chat! Guys, I'm just doing all this because I want gushers, guys. Well, obviously to learn. Guys, I just want gushers right now, guys. Like, I don't know. Alright, so the other one we have session. Okay. Alright, so let's take a drink. Alright, so once data has been correctly translated or formatted from the presentation layer, which is layer 6, the session layer, layer 5, will begin to create and maintain this connection to the other computer for which the data is destined. When a connection is established, a session is created. While this connection is active, so is the session. The session layer is also responsible for closing the connection if it hasn't been used in a while or if it is lost. Additionally, a session can contain points where if the data is lost, only the newest pieces of data are required to be sent, saving bandwidth. What is so worthy of noting is that sessions are unique, meaning that the data cannot travel over different sessions, but in fact only across each session instead. So this one is called a session. And this one is checkpoints. No. A connection. No. It's like once it's locked. Is it not like session? Yeah, bro. Like I was like, what is saying for this? Like what? So guys, this water is actually helping me to hydrate my mouth because I'm reading so much. Alright, so layer 6 of the OSI model, which is the open systems interconnections, is the layer in which standardization starts to take place. Because software developers can develop any software, such as the email client, differently, the data still needs to be handled in the same way. No matter how the software works, this layer acts as a translator for data to and from the application layer. The receiving computer will also understand data sent to a computer in one format destined for in another format. For example, when you send an email to the other user may have another email client to you, but the contents of the email will still need to display the same. Security features such as data encryption like HTTPS when visiting a secure site occur at this later. So we have presentation. That's layer X. A translator. Alright, so last one, guys. We have the last one. The application layer of the OSI. Alright, so let's just do this one. Let's remind myself that No, let's just read it real quick. The application layer of the OSI model is the layer that you will be most familiar with. This familiarity is because the application layer is the layer in which protocols and rules are in place to determine how the user should interact with data sent or received. Everyday applications such as email clients, browsers, or file service browsing software such as FileZilla provide a friendly graphical user interface for users to interact with data sent or received. Other protocols include DNS, which is domain name system, which is how website addresses are translated into IP addresses. Alright, so we did all the 7 layers. We did the open system interactions, and which has the 7 layers. If you ask me to rename the layers, I might still have some learning to do. Alright, so can you skip the OSI dungeon? Climb the levels in the correct order to escape the dungeon and reveal the flag. Can you beat our staff high score of 19 seconds? Let's see how we do. Okay, so our hacker has been logged in the dungeon. Their only Their only chance of freedom is by choosing the correct path based on the OSI model. Use your left cursor keys to move left and right, and the space bar to enter the door. So we have physical. Oh, this physical. It's physical. Okay, so you use the space bar. Is data link. Network. Transport. Session. Presentation. And should be application. There we go. So we did not beat the staff score. So let's put in the THN OSI dungeon escape. Let's go. Okay, so we did this one. Let's so I did the let's go. Yeah. Alright, so guys, before we start this one, let's before we start this one, let's go to a let's go to a let's go get our gushers. So guys, I'll be right back, and let's get our gushers. Alright, so guys, so what I'm gonna do, I'm going to take a quick break, and I'm going to um come back and keep streaming. So I'll be right back, guys. Um, so yeah, I'll be right back, and yeah, so I'll be right back. Okay, guys. All right, see you guys. All right. Hey guys, we're back. Um, we're back. It's my bad. I left for a very long time. You know, that was more than just a break. Okay. Um, I really didn't mean that. I really didn't mean to do that. Um, for a very long time. You know, that was more than just a break. Okay. I really didn't mean that. Okay, so now that we're locked back in, sorry, I had to do some I went grocery shopping. I went to Dollar Tree. I went to Waffle House. I hung out with my cousin. I got a good amount of food in my system, and I was taking my dog outside. Did I just put water all over? No, I didn't. Okay. That water does not get boring. Alright, so packing some frames. It's my bad, guys. It's my bad. We're going to complete the network of fundamentals. So packing some frames. Let's join this. Alright, so packets and frames are a small piece of data that, when forming together, make a larger piece of information or a message. However, there are two different things in the OSI model, which is open. Shoot, bro. OSI is open. Open systems interconnection. Bro, I literally said it like so many times too. A packet is a piece of data from layer 3 of the OSI model containing information such as the IP header and payload. A frame, however, is used at layer 2 data link of the OSI model, which encapsulates the packet and adds additional information such as the MAC addresses. You can think of this process as similar to mailing a letter through the post. The envelope is a frame, which is used to move the context, in this analogy, the packet of the envelope to another place. Once the recipient opens the envelope, which is the frame, they will now know how to move forward and the packet itself. This process is called encapsulation, which is what we discussed in room 3 of the OSI model. At this stage, it's safe to assume that when we are talking about anything about IP addresses, we're talking about packets. When the encapsulating information is ripped away, we're talking about the frame itself. Okay, packets are an efficient way of communicating data across network devices such as those explained in Task 1. Because this data is exchanged in small pieces, there is less of bottlenecking occurring across the network than large messages being sent at once. For example, when loading an image from a website, this image is not sent to your computer as a whole, but rather in small pieces where it is reconstructed on your computer. Take the image below as an illustration of this process. The cat's picture is divided into 3 packets, where it is reconstructed when it reaches the computer to form the final image. Packets have different structures that are dependent upon the type of packet that is being sent. As we will come to discuss, networking is full of standards and protocols that act as a set of rules for how the packet is handled on a device. With billions of devices connected to the internet, things can easily break down if there is no standardization. Let's continue with our example of the Internet Protocol. A packet using this protocol will have a set of headers that contain additional pieces of information to the data that is being sent across the network. So header time to live, which is this field. This field sets an expiry timer for the packet to not clock up in your network if it never manages to reach a host or escape. Checksum. This field provides integrity checking for protocols such as TCP and IP. If any data is changed, this value will be different from what was expected and therefore corrupt. Source address. The IP address of the device that the packet is being sent from, so that data knows where to return to. Destination address. The device IP, the packet being set, so that the data knows where to travel next. What is the name? Does have IP addressing information. Business source. Okay, so it's not in English. Okay. It does have address on. There we go. All right, TCP and IP, the three-way handshake. All right, this protocol is very similar to the OSI model that we have previously discussed in room 3 of this module so far. The TCP/IP protocol consists of 4 layers and is arguably just a summarized version of the OSI model. These layers are application transport, internet network interface. Very similar to how the OSI model works, information is added to each layer of the TCP model as a piece of data or packet traverses it. As you may recall, this process is known as encapsulation, where the reverse of this process is decapsulation. One defining feature of TCP is that it is connection-based, which means that the TCP must establish a connection between both the client and a device acting as a server before data is sent. Because of this, TCP guarantees that any data sent will be received on the other end. The process is named the three-way handshake, which is something we'll come on to discuss shortly. A table comparing the advantages and disadvantages of TCP is located below. Alright, advantages guarantees the integrity of data, capable of synchronizing 2 devices to prevent each other from being flooded with data in the wrong order, performs a lot more processes for reliability. Disadvantages requires a reliable connection with the 2 devices. If one small chunk of data is not connected, then the entire chunk of data cannot be used and must be resent. A slow connection can bottleneck another device, as the connection will be reserved on the other device the whole time. TCP is significantly slower than UDP because more work computing has to be done by the devices using this protocol. TCP packets contain various sections of information known as headers that are added from encapsulation. Let's explain some of the crucial headers in the table below. Source port. This value is the port opened by the sender to send the TCP packet form. This value is chosen randomly. Our destination port. This value is a port number that an application is running on the remote host, for example, a web server, unlike the other port. This value. Okay. Source IP. This is the IP address of this device that is sending the packet. Destination. What it's for. Sequence number. When connection occurs, the first piece of data is transformed, receiving a random number. We'll explain this more and further on. Acknowledgement number. After a piece of data has been giving a sequence number, the number. Okay. Checksum. There's okay. So initiate connection. The header and the TCP packet. Source. What's ensures the integrity of data. Ensures so first is send because ag is after. Okay. I was like, what's going on? Let's go, chat. Here I noticed that the It's like really small. Does not look good, guys. I like zoom in. Hold on. I got it, guys. Let me cook. I accidentally just flipped it vertical. Hold on, guys.
So here's how to adjust the screen size in OBS Studio. It's quite easy and simple to do, but make sure you watch.
What's up, guys? In this tutorial, I will show
So here's how to adjust and drag it up and down. Then your screen will adjust like this. The second method is to click on the screen and adjust from the corner like this. The recording screen will not change its aspect ratio. To change the aspect ratio of the recording screen, press Shift and then adjust the screen. Now you can see that its aspect ratio is changing. To reset, you can press Ctrl plus Z or go to Transform and click Reset Transform. All changes will reset. The third method is to crop the screen and then record. First, click Reset Transform. Then press Alt and adjust the screen.
So we should be good now. All right. This is fun. Like I like doing these. Like I like doing these. Like these is so cool, bro. So this means that we can go back real quick. Complete the OSR. And I guess we can also check this. And then let's do this one, guys. No. Oh yeah, should I forget it? Wait, bro, hold on, bro. There we go, bro. Lock in. Let's go. I'll let you answer this question, guys. Alright, so let's lock in. Alright, so what the freak? I got 5. Bro, like, what is his suspense, bro? See, yeah, it is 5. Let's go. Let's go. Let's go, guys. So, did I just finish it? Let's read the path. I don't know. What command pings? I feel so dumb right now, guys. Guys, tomorrow I'm gonna like actually take notes, cause like I need to take notes, you know. So I actually want to know, guys. So he's saying like all of them are wrong. Okay, retrieve. Guys, document both identifiers for network. I feel like I'm close, bro. It's not this, then it's this. Bro, why is it messing up my stuff, bro? These have to be next to each other. Bro, what? Alright, so there we go. Alright, well, You guys helping me out. I guess I hope you guys have a great rest of your day. Thanks for watching my really long stream. I took a really long break, but we got through it. We got through the pre-security about like the first half or the first like quarter of it, let's call it that. So tomorrow I'm gonna see if I can complete the next room. There's 5 rooms, so I just did the first one. So we're doing good, guys. So let's lock in and do good, guys. I'll see you guys on the next one.